Alrighty, so here we are with the next topic. The next topic is simplifying with rational exponents. Okay, so let's look at the first problem. The first problem is negative 32 to the negative 4/5. So how can you simplify this? So one of the things that we have said is this may be also a good problem where you want to switch this to a positive exponent. So what I could do next, I could just say, okay, negative 34 to, I'm sorry, negative 32. Negative 32 to the 4/5. So in this case, I have to decide, is it easier to take the root first, or is it easier to raise it to the power of 4? So you want to think of, how can you make this simpler or smaller, a number instead of a bigger number? If I raise this to the 4th power, I'm going to make it into a very large number, and it's going to be hard to manipulate. Versus if I recognize that 32 is going to be, that it's going to be a perfect 5th root, because 32, right, if you think about this as 16 and 2, this is 4 and 4, 2 and 2, right? So you have 5 of the same factors. So when I look at this, since it's negative 32, it's going to be a negative. So this is going to be, I'm just going to rewrite it like this, just so you can see what I'm talking about. So I'm going to say this is the 5th root, and then raise that to the 4th power. So the 5th root of negative 32 is negative 2. Then if I raise that to the 4th power, it's going to be a positive number because I'm raising it to an even root. So that is going to be 16. So it's 1/16. Okay, let's look at another problem. Let's look at negative 5x to the 5/3 times 3x to the negative 3/4. Okay. So in this case, what I like to do is I like to combine the numbers with the numbers and then the variables with the variables. So I like to separate them. So I like to do this negative 5 times 3, right, times positive 3. And then the x 5/3 times x to the negative 3/4. You could do the addition right here, right? Because we know that x squared times x to the 3rd is equal x squared plus 3. So when you multiply variables with exponents, you add the exponents. So in this case, you could do that. But one of the things that I want you to notice is that if we were to change this second term right here to a positive exponent, the way that would look like is we would write, so x to the 5/3 times 1 to the x to the 3/4. So that is a fraction, okay? So whenever you have a fraction, you have to make sure to note that the fraction does not exist with the denominator equals to 0. So I'm going to show you how to do that. So let me go back this. So negative 5 times 3 is negative 15. So now I can just combine this and have x 5/3 or x to the 3/4. So this I have to do 5/3 minus 3/4. So I have fractions with different denominators. Since I have fractions with different denominators, I have to make them the same denominator. So the LCD right here is going to be 12. So to make this to 12, I have to multiply this by 4 and 4. Remember my fancy one. And this one I have to multiply by 3 top and bottom because I want the denominators to be 12 for both of them. So that gives me 4 times 5 is 20 divided by 12 minus 3 times 3 is 9 over 12. So 20 minus 9 is 11, 11 over 12. So for this problem, that gives me negative 15 times x to the 11 twelfths, okay? And you're almost done. Remember how I said the denominator cannot be equal to 0? So this right here, if x is equal to 0, then this function would not exist. There would be an asymptote right there. So what you have to say is x cannot be equal to 0. That's another, something else that you have to include. Okay, part C. So let's say you have 125, the square root of 125, so the cube root of the square root of 125. That's a mouthful, right? So it's the cube root of the square root of 125. So one of the properties says that when you have this root right here, the index is 2, what you have to do when you take the root of a root, the rule is that you have to multiply that. So the indices, so 3 times 2 of 125, so this becomes, that's a big 6. So this becomes the 6th root of 125. And the 6th root of 125, let me just see. So I want to see if there is, if you can simplify this. The closest that I can think that you can simplify this as, it's not a perfect 6th root, but what I could simplify this is I can know that 5 times 5 is 25, 25 times 5 is 125. So I have a 3rd root, and that's going to help me simplify it a little bit, because I can write this as 5 cubed raised to the 6th root of 5 cubed. So if I rewrite this in exponential form, I have 3 to the 6th, which is the same thing as 5 to the 1/2. So I'm saying that the 6th root of 125 is the same thing as the square root of 5. So I simplified it a little bit. Okay. Last but not least, let's do this one. E. So 2x minus 1 raised to the 4/3 times 2x minus 1 raised to the negative 1/3. And if you say, I'm going to change this, there are different strategies that you could do to solve this problem, but the one that I'm going to do is, just so you can see that this right here ends up being a fraction, I'm going to switch this to a positive exponent. So that leaves me with 2x minus 1 to the 4/3 times 1 over 2x minus 1 to the 1/3, which is the same thing as 2x minus 1 to the 4/3, 2x minus 1 to the 1/3. So if you notice right here, is that 2x minus 1 is the base, so they both have the same base. So what I could do is 2x minus 1, 4/3 minus 1/3, that equals to 2x minus 1 to the 3/3, and 3/3 is 1. So I just have 2x minus 1 is my answer, but I also have to double check when the denominator equals to 0, right? Because the function cannot exist there, and the way that I do that is I take the denominator and set it equal to 0, so 2x minus 1, set it equal to 0, and I solve for x. So plus 1 on both sides, that gives me 2x is equal to 1, divide both sides by 2, that gives me x is equal to 1/2. So it's saying this function, right, it's 2x minus 1 everywhere except where x is equal to 1/2. So x cannot be equal to 1/2, okay? So here we have a few more examples on how to simplify with rational exponents. If you have any questions, please feel free to contact me, okay?